Okay, in this video, we're going to talk about angle addition formulas for trigonometry. So let's look at what those formulas are. So we have three. We have sine of A plus or minus B, and this is an identity, should be equivalent to sine of A cosine B plus or minus cosine A sine B. And so if you look at this, an important thing to see is that this sign, this plus or minus, is the same as this one. That means that no matter what you're given in the problem, you're going to use the same sign. For example, if I had sine of A plus B, then when I did this, I would get sine of A cosine B plus cosine of the first angle and then sine of the second. So this is the first angle, this is the second. But if I have plus in my problem, I'm going to use plus here. However, if I had sine of A minus B, then I would use sine of A cosine B minus cosine of A sine B. So this one's nice because whatever you see in the problem is the sign that you're going to use between these. But for cosine, notice that where we see plus or minus here, you see that this sign is flipped here. That means use the opposite sign. Okay? So, if I have cosine of A plus B, and notice this formula is different. This is cosine of the first angle, cosine of the second angle. But I'm going to use the opposite sign. So if I had a plus here, I'm going to have a minus here. And then sine of the first angle, sine of the second angle. Okay, so you have to be careful, and these formulas are on your reference sheet, so you should use that. But this would be the formula. And then again, if I have cosine of A minus B, I'm going to have cosine of the first angle, cosine of the second. That part's the same, but if this is subtraction, then I'm going to use addition here. And then I will have sine of the first angle, sine of the second angle. So you just need to be careful and watch those signs. We do have a tangent formula out here. What I want you to notice on this is that this is plus or minus and this is plus or minus. So this one's going to be the same, but this one down here is actually going to be the opposite. So if you started with a plus here, you'll use plus on the top and then minus. But if you started with subtraction here, you would use subtraction and then addition. So the top one is the same sign and the bottom is opposite. Let's look at a couple examples of how we can use these. So in this instance, we're just asked to simplify this. We're given cosine of the quantity 3 over 2 pi minus theta. Okay, all of this is inside our cosine, and we're just asked to simplify. So since this is cosine, I'm going to use one of my cosine formulas. So I'm going to have cosine of the first angle times cosine of the second angle. And we're going to use the opposite sign. So since that's minus, we're going to use plus. And then we're going to have sine of the first angle times sine of the second angle. And then we can simplify this because we can figure out what cosine of 3 pi over 2 is. Cosine of 3 pi over 2 is 0 times cosine of theta plus sine of 3 pi over 2 is negative 1 times sine of theta. And so since 0 times cosine is 0, we don't need to write that. And negative 1 times sine is just negative sine of theta. And so this would be my simplified answer. Okay, let's look at this example. We're asked to prove that this identity is true. Now, you remember when we're proving identities, we get to pick one side and work with it. There are a few other options, but I can't work with both sides. And so in this instance, I see sine and I see an angle addition, angle A plus angle B. So I'm going to use my angle addition formula. And I'm going to start here and I'm going to say sine of angle A times cosine of angle B. So be careful, that's different than our cosine formula. Sine stays the same, and then I have cosine of angle A, sine of angle B. So this is all just this part. Plus, now I'm going to do this one. So I'm working on this one now. So that's going to be sine of the first angle, cosine of the second. Use the same sign, minus cosine of the first, sine of the second. And now our goal is to come out with 2 sine A cosine B when we're done. Now, if you look at this and we look at like terms, this is the same term as this, cosine A sine B, cosine A sine B. So if I have one that's positive and one that's negative, those will cancel out. And so I have sine of A cosine B plus sine A cosine B. And the goal was to get to this, 2 sine A cosine B. And even though there's a lot going on in here, if you notice sine A cosine B, sine A cosine B, these are exactly the same. So there's like terms, and there's 2 of them. So this side does in fact equal to sine A cosine B. So we proved our identity in that case. Okay, in this example, we need to express tangent of 3 pi over 4 plus x in terms of tangent x. So that's just telling me that I still only want tangent of x in my answer. And I see that I have 3 pi over 4 plus x. So I have this angle plus whatever this angle would be. That's an angle addition formula. And so I'm going to have tangent, if we look at our reference sheet or we look at the formulas that I gave you at the beginning, I'm going to have tangent of A, which is 3 pi over 4, plus, I'm using the same sign, tangent of the second angle, which in this case is x, over 1, now this is where I use the opposite sign, so these 2 signs will be opposite, minus tangent of the first angle times tangent of the second angle. And then we're just going to simplify as much as we can. So tangent of 3 pi over 4 is actually -1. So on the top I have -1 plus tangent of x. And then on the bottom, I'm going to have 1 minus, remember this part is -1, so be careful with your signs, times tangent of x. And so this double negative is going to make this on the bottom positive. So I'm going to have 1 plus tangent of x over, I'm sorry, that was -1 plus tangent of x over +1 plus tangent of x. So now be careful because I can't actually cancel anything out since this is negative and this is positive. So I am done. And this would be my answer. Okay, let's look at one more. In this case, we want to find the value of tangent of x. Given that sine of x plus 30 degrees is equal to 2 cosine of x minus 30. Again, I see an angle plus an angle, angle minus angle, so I'm using my angle addition formulas, even though some of them we have subtraction in there. So I'm going to do this part. And that formula is going to be sine of x, cosine of my second angle. Use the same sign when we have sine out here. So plus cosine of the first angle times sine of the second equals. Now be careful with this part. This is 2 and you need to put brackets because this is 2 times everything that equals. So that's going to be cosine of x, cosine of 30. But we use the opposite signs when cosine is out here. So we're going to use plus. And then I'm going to have sine of x times sine of 30. Close my brackets. Okay, now we can simplify this a little bit. Cosine of 30 is actually equal to square root of 3 over 2, which I could put here, but I'm just going to move it in front of my sign. So I have square root of 3 over 2. That's what cosine of 30 equals. And then I'm going to put the sine x next to it. Plus, sine of 30 is 1/2, but I'm going to move it in front. So I'm going to have 1/2 cosine of x. And that's just because I like to have my numbers in front of my trig functions here if I can. Equals 2 brackets. Remember, cosine of 30 is square root of 3 over 2. And I'm going to put cosine x next to it. Plus, sine of 30 is 1/2, and I'm going to put the sine of x next to it. Now, I do want to go ahead and distribute that too. So I'm going to have square root of 3 over 2 sine x plus 1/2 cosine of x equals 2 times square root of 3 over 2 is just square root of 3 cosine x. And 2 times 1/2 is 1 sine x. So I'm looking pretty good so far. And this is just like the regular algebra that you're used to, even though we have trig in it. I want to combine like terms. So I want this sign to be with this sign. So I'm probably going to move this sign over here. I'm going to subtract. Okay, and now I'm getting kind of shy on room here. So I want to do that math, but I also want this cosine to be over here. So I'm going to subtract 1/2 cosine from this side, which will cancel this one, and move it over here. So when I do all of that, I have square root of 3 over 2 sine x minus sine x equals square root of 3 cosine x minus 1/2 cosine x. And since these are like terms, that's like square root of 3 over 2 minus, there's a 1 there, okay? And you can do that math and figure out what it is. I like to actually take out a greatest common factor of sine x, which is going to give me square root of 3 over 2 minus 1. Okay, that's what we would have done. That's the math we would have done. But then I can leave it here and I can either choose to simplify it or not. If I take out a cosine here, I get square root of 3 minus 1/2. Now everything's looking good because now I only have one sine and one cosine. But look at what you were asked to find. We want to find the value of tangent of x. So what we have to do is think about how would I make tangent of x out of sine x and cosine x? Well, if I divide by cosine x here, because this is just multiplication, this is cosine of x times this. Okay, if I divide by cosine of x, sine x over cosine x is tangent x. And so I actually get tangent of x times square root of 3 over 2 minus 1. And in this case, I don't have this anymore. That's 1 times, and so all I have left is the square root of 3 minus 1/2. And finally, since we want the value of tangent x, it didn't ask us to solve all the way for x. We just want to know what tangent x is equal to. I can divide by all that. And I know that's getting kind of squished there. But what I would get is I would get the tangent of x is equal to square root of 3 minus 1/2 over square root of 3 over 2 minus 1. And now I could simplify this in a lot of different ways. I could multiply by 2 over 2 to clear my fractions. But really, for us, we're kind of done because that's the value of tangent of x. If I wanted to solve for x, I would need to do some more. But again, this right here can be written in many different ways. So there's several different ways to simplify it. Don't think your answer's wrong if yours doesn't look just like somebody else's. Check to make sure that it's equivalent. Okay? All right, I will see you guys in class.